Good morning, everyone, and welcome to today's lecture. This is lecture number 16, and we are dealing with motion in a vertical circle. The previous class, we had seen some important results, and we had seen how particle moves in a vertical circle. We had seen the equation at various points, lowest point, middle point, highest point, on the left side middle point. Then we had seen at points in between A and B, in between B and C, and we had written some important points about what is happening where, and where is the tension highest, at which point is the tension highest. Do we remember at which point is the tension highest? No one remembers it? Okay, I'll give you 5 minutes. Go through this so that we can go ahead. Let me know once you are done. Coming back to my question, at which point is the tension highest? At which point is the tension highest?
At A, sir.
What is A? What is A? I'll give you 5 more minutes. Go through it and then we will come back. So, the moral of the story is if you don't read, we will be wasting important time in the class, and that will not serve any purpose to anyone. So, I would suggest and sincerely request that if you are coming to this class, please be prepared of what we had done in the previous class, else the class would be of no use. Anyways, having said that, we have seen the simple things. We had made equations at different points, and we have seen what happens at all points. Now, what we see is the condition of looping. Condition of looping in this case. What do you mean by looping? Condition of looping. Looping means condition to complete. Condition to complete. Circular path. And reach the highest point C. That is what we call the condition of looping. We have to complete the circular path and reach till point C. Now, in this case of body attached to a string, what is the condition of looping? What is the condition of looping? What can I say? That if I have to complete the loop, what should be the condition so that this ball can go from the lowest point A to the highest point C? What would be the condition?
0.
What 0? What is the condition of looping? To complete the circular path, what should be the condition? What condition should I put so that this bob or this ball or whatever is attached to this string can go from the point A and reach the highest point C?
Velocity decreases.
The condition is tension at point C should be greater than or equal to 0, because if tension at any point between B and C becomes 0, it will leave the circular path and follow projectile motion. To just reach point C, I'm writing all these points, but I don't think this is of any use, because you don't understand anything and you don't remember anything. But still, it is my job that I must write it, and my entire hard work is going down the drain of Hyderabad. Anyways, I will fill up Hyderabad drains. That's my job. To just reach point C, just need to reach point C. Then tension at point C would be 0. So I will just reach point C and just complete the loop. So to just reach point C, the tension at point C should be equal to 0. Now we have to understand what will be the condition at the lowest point so that I can reach the point C. So the next heading is to just reach point C. What should be the condition to just reach point C? And how do I find out that condition? I draw a circle to just reach point C. This is the center. The length of the string is L, and the bob is having a mass M. Now this was your point A, this was your point B, and this was your point C. I have to just reach point C. The speed at point A is VA. To just reach point C, I have to just reach point C. The bob just needs to reach here. The first condition is tension at point C would be equal to 0. Tension at point C would be just equal to 0. Now, if I know that the tension at point C is just equal to 0, you should be able to tell me what should be the velocity at point C. So I ask you, what would be the velocity at point C?
0.
I know that you don't remember what we had done in the previous class, but I think that you have made notes. So go back to those notes and tell me, I know that the tension at point C is 0. Please go back to your notes and see if tension at point C is 0, what is the velocity at point C? And that is why those equations and those notes were made. Please go back and tell me what is the velocity at point C when the tension at point C is 0. That is what happens when you don't
Under
come
root
prepared. Yes, beta, how much?
under root LG.
Wow, good. Under root GL. Under root GL would be the velocity at point C. Now, how did this magic happen? That knowing the tension, we can calculate the velocity. That is what we had done in the previous class, and I am not going to repeat it. If you understand, you understand. If you don't understand, go back, study, and then come back. Okay, now we know the condition at point C. Now from that, we have to find out the condition at point A. Now, how are you going to find out that condition at point A? I will tell you the process, but then I will simply tell you the result. You will have to apply your law of conservation of mechanical energy from A to C. Total mechanical energy at point A should be equal to total mechanical energy at point C. I know that you would have forgotten what is this, so I'm not expecting you to remember it. If you can't remember what happened in the previous class, this happened ages ago. So don't expect that to remember it. So I will tell you that. Anyone remembers, by the way, what was law of conservation of mechanical energy? Just by a chance, someone remembers? Does someone remember it by chance? As I said, okay, if you remember it, well done. If you don't, I have no.
If only constant force are present.
If you don't remember it, no matter. I don't expect that you would remember it. Mechanical energy at point A will be equal to mechanical energy at point B. That was it. So kinetic energy at point A. Now, if I write kinetic energy at point A, that will be equal to half m into VA square. Potential energy at this point, I will take it as 0. So kinetic energy at point A plus potential energy at point A will be equal to kinetic energy at point B, half mvb square, plus potential energy at point not B. I must write point C. I've written it wrongly. I'm not writing it from A to B. I'm writing it from A to C. So kinetic energy at point is C plus potential energy at point C. The lowest point potential energy is 0. So highest point. Anyone remembers how it be? What will be the energy at the highest point? The energy. Yes.
2 mgl.
2 mgl because it is 2l above. Chalo, we remember it. mg into 2l. Now, once you put the value of velocity at point C from here, you will get the velocity at point A from here. I will leave the calculation for you. I will just tell you how much that velocity is coming. Velocity at A from this equation, when you solve it, you will get it as root 5 GL, and this task of solving it and getting the answer is left for you to do it. So leave some space and you will do it at home. Now, once I know the velocity at point A, is root 5 GL, I can find out the tension at the point A. Now, I'm not going to tell you how it is done because we have already covered it in the previous class. So, once I know the velocity at point A is root 5 GL, can you tell me what is the tension at point A? Can anyone tell me what is the tension at point A? Velocity at point A I will get from this red equation. How will I get the tension at point A? What will be the tension at point A? No one knows it? How much is the tension at point A?
mv square by L.
6 mg. That is what you will get, 6 mg. And how do we get this? Well, in the previous class, we had made some equations. Here are those equations. I know that you don't remember it, but if you can just go back and see those equations, and I will not do it for you because if I do everything and I've been doing everything, that is making you more and more weak. So once you put the value of velocity of A, and in this equation, you will get the tension at point A If you put the velocity, if you put the tension here as 0, you will get the velocity at point C. I am not going to do it for you. You are the one who are going to do it on your own. So this is what we will get. These are the equations we have already made. I hope and I pray to God that you remember these. The only way you can remember this is when you go back home and read what we had done in the previous class, which I hope that will happen before I see the last day of my life. There would be some day that would come where I would find you, sir. We have read what you had studied, what we had done in the previous class. There would be one day that will happen, and I have full faith in that day, and I'll wait for that day. When that day comes, surely today is not the day, but that day will come. So this is the condition. This is the condition. This is the condition. This is the condition. This is the condition to complete the loop. And what is the condition to complete the loop? The condition to complete the loop, you can say it in any of these ways, but the best way to say this, the condition to complete the loop is velocity at the lowest point should be root 5 GL. If the velocity at the lowest point is root 5 GL, if the velocity at the lowest point is root 5 GL, if the velocity at the lowest point is root 5 GL, if the velocity at the lowest point is root 5 GL, the particle completes the loop. So, to just reach point C or to complete loop, what are the conditions? Number 1, tension at point C is equal to 0. Velocity at point C will become root over GL. Tension at point A will become 6 mg. Velocity at point A should be root 5 GL. This is the condition for completing the loop. Now, what all question can be asked here? So what I will do is that I will make a table here. A small table. This is not looking good. I will try to make it this way. I'll make what has happened here. Something happened. Okay. So I made a small table here where I will write all the values A, B, and C. Velocity and tension. These are the two things. Velocity at point A is root 5 GL. Then the velocity at point C becomes root GL. And if you again apply this yellow theorem, instead of applying it from A to C, if you apply it from A to B, you will get the velocity at point B if you know the velocity at point A. I will again leave that task to you. Once you do that exercise, you will get velocity at the lowest point is root 5 GL, then the velocity at the middle point will come as root 3 GL. It always comes like this because the relation remains constant. The tension at point A, which is the lowest point, becomes 6 mg. The tension at the highest point becomes 0, and the tension at this point becomes 3 mg. There is a certain relation that you can see from A to B to C, whether you talk in terms of velocity or whether you talk in terms of tension. You can see a relation. I will not tell you what that relation is. This is how the relation looks like. There is a pattern, not a relation. There is a pattern that you see between the three velocities. There is a pattern that you see. If you look closely enough, you will see a pattern between these three velocities. If you look closely, you will see a pattern between these three tensions. You will also see a pattern between the velocity and tension. If velocity is root 5, tension is 6. Velocity is root 3, tension is 3. So there is a pattern. If you can understand this pattern, it becomes easy. So this is the condition to reach point C. I'll give you 2 minutes to note down this condition. Once you are done, please let me know. And I will hope that you will remember this. Everyone is noting it down. There is no point of noting it down because it's of no use. As I have seen that you just note down something and you don't understand what you are noting down. I asked at which point the tension is lowest, tension is high, you said point A, but you even did not know where is point A. So you have just noted down everything from the board. That is evident. There is no point of noting it down. Don't note down anything. Just don't write any single word of what I say. You always have my lecture to see. You can always see that. The only thing is that you understand. Writing notes is useless if you don't understand it. Because I know that you are not going to read it at home. You don't read it at home. There's no point of writing a note when you are not going to read it. So what do? You at least understand in the class. That is what I will suggest. Understand what we are doing. Writing notes is irrelevant. I'll give you 2 minutes in any case. Right, we always move ahead. We have seen the condition to reach the highest point C. Now we'll do one more condition to reach the middle point B. What should be the condition to reach middle point B? Again, as a routine, I shall draw that circle. That circle has been drawn again. That circle has been drawn again. Smaller circle because I don't need to do anything else. This is length L. The bob is here. Mass M. It just now wants to reach from A to B. Can you tell me what should be the condition that it just reaches point B? To just reach point B, should not go any further. To just reach point B, what would be the condition? Anyone? No one knows it. So the condition would be
Tension velocity can't be zero.
tension at point C should become 0. Just reaches that point. But the good thing is, as soon as the tension at point C becomes 0, one more thing becomes 0 automatically.
Velocity.
Yes, the velocity automatically becomes 0 because if you look at the equation which we had done in the previous class, when you look at the equation, as soon as the tension at point C, tension at point B becomes 0, look at this equation which I am going to mark by green. As soon as the tension at point B becomes 0, the velocity automatically becomes 0. We have also noted it down in the notes. We have also noted it down in the notes. I know you have written it, but there is no point of writing it when you don't remember it or understand it. So as soon as tension at point B becomes 0, the velocity also becomes 0. Velocity also becomes 0. So that is the first two conditions that we understand, but you must remember that we are more interested in knowing what should be the velocity at the point A for this to happen. We are more interested in knowing what is the velocity at point A for this to happen. Now, how will I find the velocity at point A when I already know the velocity at point B? What should I use to do this? How will I get the velocity at point A? I know the velocity at point B is 0. How will I get the velocity at point A? No one knows it? I will apply law of conservation of mechanical energy from A to B. Total mechanical energy at point A will be equal to total mechanical energy at point B half m into VA square. I will call the potential energy of this point as 0 plus 0 will be equal to half m VB square, which is also 0, plus the potential energy, and the potential energy of this point will be equal to mgl. From this equation, you will get the velocity at point A. Can you tell me what will be the velocity at point A coming from this equation? I'll give you 2 minutes to do that. Yes, it will come as under root 2gl from this equation. Applying this equation, it will come as under root 2gl. Now again, I'll give you 1 minute. You know the velocity at point A is under root 2gl. Can you tell me what will be the tension at point A? And I had given you some hint of finding out the tension when velocity is given. What will be the tension at point A? And what will be the velocity at point A? Velocity at point A, I have already got it. It is root over 2gl. What is the tension at point A going to come? Yes. What is the tension at point A going to come?
3 mg.
Well done. So now you have understood the concept probably, and you are ready to use the equation. Once again, I will repeat what is the condition to just reach point B. Tension at point B becomes equal to 0. Velocity at point B also becomes equal to 0. Because of that, what do I get? Tension at point A becomes 3 mg, and velocity at point A becomes root over 2gl. If I now make my famous box, famous or infamous, whatever you call it. Now if I make my famous box, in this famous box, I have to only write 2 points because there are only 2 points, point A, point B. If I talk about velocity and if I talk about tension, you will again see the same relation coming, that velocity is root over 2gl, root over 2gl, root over 2gl. Tension is 3 mg.
3 mg.
The velocity at this point, from root 2gl, it becomes 0. And from 3 mg it becomes 0. You will see the same pattern here as you saw the same pattern there. I don't know what is there. You will see the same pattern here that you saw the same pattern there. I will again not tell you what is here and what is there. Do we understand this, or this has gone above our head saying bye bye? Bye bye. Anyways, it is going to go above our heads tomorrow. But right now, has it gone into our head? Tomorrow it is definitely out of your head. But today, let's talk about the present, my dear friends. Let's not be worried about the future. What is going to happen tomorrow? Let us put it to the dustbin. Right now, do we understand this, everyone? The people who are sitting in dark and I cannot see. Live in today. Don't worry about the future. Tomorrow, no one knows. Tomorrow never dies. One very famous Bond movie that came when I was of your age, not of your age, 1 year elder to you, first year of college. P.S. Brosnan, my favorite Bond, the Bond which I saw in my good days. Anyways, now we have got two velocities, and now let me just write what we have achieved till now. Important notes again. They are important right now. Tomorrow they will be useless because we will not remember it. But still, we can't worry about tomorrow. We have to worry about today. Important points. Number one, if velocity at point A is root over 5gl, we have seen this case. It just reaches point C. Do we understand this? We have seen the tensions and velocities at different points. Do we remember this? I'm talking about the present. I'm not talking about the future. Do we remember this now? Okay. Then the second velocity we have found out. If velocity at point A is exactly equal to root over 2gl, then it just reaches which point? Just now we have seen 2 minutes back. That is also present. We can't call it past. Yes? See? 5 minutes before we have, not even 5 minutes, it was just 2 minutes before it. If velocity at point A root over 2gl, where does it go?
Tension B.
Huh?
B.
It just reaches point B. Now let us go further less. If velocity at point A is greater than root over 5gl, it completes loop. It completes loop. The velocity is more than this. It will complete the loop. What will be the tension at point C? Will it be 0 or will it be more than 0?
Greater than or equal to 0.
Array equal to cannot happen, bhai. Equal to cannot happen. Equal to is at root 5gl. It is greater than root 5gl. This is simple maths of third standard.
0.
Greater than 0. It will be greater than 0 and velocity at point. See, this is simple maths. I can't teach you this much of maths because that would be very sad day. And velocity at point C would be greater than root GL. Do we understand this? Today, present, we are talking. I'm not worried about the future. Boys in the dark. Next case number 4. If velocity at point A is less than root 2GL, then what will happen? Less than root 2GL. It will oscillate in lower half. It will keep on oscillating in the lower half. Tension will always be greater than 0. But at some point, velocity becomes 0. Do we understand this? At whatever points the velocity becomes 0, it will go to that point and keep on ding, 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 ding. Do we understand this? Ding, 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 ding.
Sir.
Tension will never become 0 because in the lower half, tension cannot become 0. So we'll keep on going like this. At some point, the velocity will become 0. It will go to that point, come back, and it will enjoy its life. Swinging. Just one condition is left. Which condition is left? Again, this is very simple. I have seen the condition when velocity is less than root 2gl. I have seen the condition when the velocity is more than root 5gl. I have seen the condition when velocity is equal to root 2gl. I have seen the condition when the velocity is equal to root 5gl. One condition remains. What is that condition? What is that condition? What is that condition? Condition number 5. What is that condition? Sir, all conditions are done. Giving you time to show your talents. This is not a question of physics. This is a question of not second standard. My son is there. Third standard. Yes. So the condition that is left is root 2 GL is less than VA is less than root 5 GL. So velocity at the lowest point is greater than root 2 GL but less than root 5 GL. What will happen? Tension will become 0. Tension will become 0 at some point. Where? Between B. B is the middle point, C is the highest point. Between B and C, and it will leave the circular path. It will leave the circular motion and follow projectile motion. Do we understand this, or this has gone above or at saying bye bye, sir? I'm going, sir. I'm talking about present. I'm not talking about what will happen when you come to the class tomorrow. And when you come to the class tomorrow, please be prepared with all this that we have done. Otherwise, today's class will also go down the drain. And someday, that Municipal Corporation of Hyderabad will come and catch me. Sir, you are putting too much things in the drain. We will catch you and put you in prison for putting so much of things in the drain. And I hope this does not go down the drain. Is it going down the drain? Yes or no? Yes, it is going down the drain. I hope this is not going down the drain and this will remain in your system for as long as possible. On that positive note, I will end today's class. Remember why I keep on insisting, because if you don't remember what we had done in the previous class, because next class has to start from here. If you don't remember what was happening in the previous class, you will not understand anything in that class. So please, humble request once again, sincere humble request, please, and I fold my hands also, please come tomorrow prepared with the class of today. Take care, and may God help you, may God bless you, and may God give you that wisdom to listen to what your teachers say. Bye bye. God bless you all.